All right, so let's try an example. So here we have an equation g of x equals negative x squared plus 4x plus 1, right? And real quick, just on the g of x, that's just the name of the function, basically g of x. And so remember, it's not g times x, it's g as a function of x, right? So x is the input, and then g of x is the output, okay? All right, so let's do, even though we have an order here, but let's pick the easy ones first. Okay, opens up or down, we can see that just by looking at it, right? So opens up or down, we want to look at a. Opens up means a is positive, opens down means a is negative, right? So in this case, a equals, that's right, -1. And so since a equals -1, obviously that's negative, and so the parabola opens down, right? All right, so then we have our y-intercept, right? I think that would be the next easiest thing to find. So the y-intercept, that's just going to be equal to c, right? Or that's going to be at least the y coordinate, and so there's our c is 1, right? So we're just going to put 0, 1, right? When x equals 0, y equals 1, that's on the y-axis. All right, so now let's check out the axis of symmetry, okay? Also known as the line of symmetry, right? And so remember, that's going to be x equals negative b over 2a, right? It's part of our quadratic formula. That's where we get that. And so in this case, b is 4 and a is -1, like we talked about. So we're going to plug those in. So we'll get 4, and then negatives there built into the formula, over 2 times -1. Okay, so it'll be -4 over -2, which equals +2. Okay, so the axis of symmetry, or the line of symmetry, is x equals 2, right? So it's not just 2, it's x equals 2, right? It's a line, so we want the whole equation of that line, okay? So don't forget the x equals with these, and it'll always be x equals with quadratic functions, right? So later on you might get to conic sections where you might have parabolas that face sideways, and then you might have some y equals axis of symmetries, but in our class, we're not going to get to that point. And so all of your lines of symmetry are going to be x equals a constant. All right, so now that we have the vertex, that makes it easy to find, or excuse me, now that we have the axis of symmetry, it makes it easy to find the vertex, right? The vertex is -b over 2a comma f of whatever that is, right? The output, whenever that's the input. So we know that -b over 2a is 2, right? So now we just need to find f of 2 in order to find the output. So it's going to be -2 squared plus 4 times 2 plus 1, right? So I'm just plugging in 2 for x. And now we'll evaluate this, so it'll be -4. This negative doesn't get squared, so it'll just be -4 plus 8, which is 4, and so plus 1 is 5, right? This comes out to 5. So 2, 5 is our vertex. So that's the first thing we can kind of plot, right? I guess we could plot the y-intercept. So let me plot that. The y-intercept is 0, 1, so that's right here. The vertex is 2, 5, so 2, then 1, 2, 3, 4, 5. We know it faces down, right, which makes sense because we're going to head down towards our y-intercept there to connect the dots. So now the maximum or minimum value. So since this opens down, it's going to be facing like that, right? So are we going to have a maximum or are we going to have a minimum? We're going to have a maximum, right? If it's facing down, then we have a top of the mountain, right? We have a mountain shape, and so we're going to have a top or a maximum, okay? So maximums happen when a is greater than 0, when a is less than 0, and minimums happen when a is greater than 0. All right, and our minimum our maximum value in this case is going to be our vertex, right? So it'll be max at 2, 5. So this will be the top of our graph, right? There won't be anything above that. Okay, and then our x-intercepts. So for our x-intercepts, we're going to have to plug this into the quadratic formula or factor, right? So I'm going to use the quadratic formula because I don't know if this is factorable yet. So it'll be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a, right? Or 2a. All right. So go ahead and work that out. All right, so I worked out the quadratic formula here, and so basically I simplified to this, but now, you know, it's once again hard to graph, and so what I did is I plugged in the value when this is positive, right, and plugged that into my calculator. I used alpha y equals 1 to get to fraction form, and then to get the radical, you have to do second x squared. So anyway, that's how you get that, and then it comes out to approximately negative 0.24. I round to the nearest hundredth. Then I went up and selected in my calculator that same expression again and push enter, and then that allows me to edit that line, and so I changed it to a negative and push enter again, and it gave me approximately 4.24. Okay, so now I can graph these. So let me graph them in a different color here. So let's use this purple color. So negative 0.24, so that's just a little ways to the left of the y-axis, and then we have 4.24, which is about right there, right? Okay, all right, and so let's see, so those points, that's when y equals 0, right? So I have negative 0.24 comma 0 and 4.24 comma 0, right? Those are our x-intercepts. And then fifth point, a good way to find the fifth point is to just use your axis of symmetry here to mirror or map the y-intercept across, right? So since we have this point on the y-intercept is 2 units away from the axis of symmetry, I can go 2 units the other direction, and there's my fifth point. Okay, so my fifth point would be, let's see, 1, 2, 3, 4, comma 1. All right, so those are all our key points, and now we can graph our parabola. So, you know, it still can't graph it perfectly, of course, because you can't know all the points and it's curving, so it's going to be some human error here, but we have a pretty good idea of what the shape will be, right? And so that's how we graph parabolas.